the hybridization of XeF4 xenon tetrafluoride is sp3d2. So expected will be octahedral, but in the figure here, why they have shown it as square planar? That is what we are going to discuss here now. So they have clearly given that it is second excited state. So how do you predict the hybridization of this molecule? Xenon tetrafluoride. So xenon ground state, electronic configuration. So 5s. Ground state vacant d orbitals will be available. All of you know this. We've been discussing for a quite long time. First excited state, once again this is 5s. So during the first excited state, one of the electrons will get unpaired from the 5p orbitals to go to the 5d orbitals. Now you want 4 fluorine, so if you have 4 unpaired electrons, only 2 unpaired electrons are there. Go to the second excited state. So here you have 5s. Going to the second excited state, p orbital. Two unpaired electrons on 5p and 2 unpaired electrons on 5d. Now see, first fluorine forms a covalent bond with this molecule. Second fluorine forms one more covalent bond with 5p. Third fluorine forms one more paired electron. Fourth fluorine gives one electron. So now you predict the hybridization of this molecule, where you will get S P3 D2. So S P1 P2 P3 D1 D2. Expected, what you will expect according to VSEPR theory. According to VSEPR theory, what you will expect? Octahedral. But is it octahedral? No, it is going to be square planar. So how do we draw the structure? Xenon, first fluorine, second fluorine, third fluorine, fourth fluorine. Where are the lone pairs? 2 lone pairs are there. So the lone pairs are available like this. One lone pair like this and the other lone pair like this. Therefore, the actual shape of this molecule is square planar. And here this dipole is cancelled by this dipole and this dipole is cancelled by this dipole. Therefore, dipole moment is equal to 0. Right?